July 27th, 2026. What happens when the one place a country believed could never be touched suddenly becomes reachable? What does it mean when a mountain built to hide a nuclear program starts looking less like a shield and more like a trap? For more than a decade, one location inside Iran sat at the center of nearly every serious conversation about nuclear risk in the Middle East. It wasn't Iran's largest nuclear site. It wasn't even the first one built. But it was designed around one brutal idea. If the greatest danger comes from above, disappear beneath the ground. That place is Fordo, a uranium enrichment facility buried inside a mountain near the Iranian city of Qom. For years, it existed in a strange in-between space, somewhere between secrecy and open knowledge. Satellite images captured pieces of it. Intelligence agencies tracked construction happening around it. Once its existence became public, the facility never escaped global attention again. For Iran's leadership, it represented resilience, a hardened answer to decades of sanctions, sabotage, and military threats. For Israel, it represented something far more alarming. Proof that Iran wanted an enrichment capability specifically built to survive an air attack. For American military planners, it became one of the hardest targets conventional weapons had ever been asked to destroy. Then in June 2025, that long-running engineering puzzle was finally tested in real combat. The United States launched a coordinated strike against 3 major Iranian nuclear sites, Fordo, Natanz, and Isfahan. 7 B-2 stealth bombers carried massive bunker-busting bombs, each weighing close to 30,000 pounds. Dozens of cruise missiles struck other parts of Iran's nuclear infrastructure from a separate direction. It marked the first combat use of the largest conventional bunker buster in the American arsenal, and it became the longest B-2 combat mission ever flown. But the number of aircraft, the size of the bombs, none of that is really the heart of the story. The real question is why a weapon like this had to be built in the first place, what kind of target it was meant to defeat, and what actually happened after it slammed into a mountain experts once called nearly impossible to penetrate. But let's back all the way up, because to understand why Fordo became such an obsession, you need to see where Iran's nuclear program actually started. It didn't begin as a straightforward push toward a bomb. Before 1979, Iran's monarchy cooperated openly with Western countries on civilian nuclear energy. After the revolution that year, those partnerships collapsed almost overnight, but the broader belief that nuclear capability represented national power and scientific independence never went away. Over the following decades, Iran's nuclear activity became one of the most contested subjects in international diplomacy. Iranian officials consistently said the program existed for peaceful purposes. Critics pointed to enrichment levels, undisclosed facilities, and capabilities that seemed hard to justify through civilian energy needs alone. Sanctions expanded, negotiations opened and stalled and reopened again. Behind every round of talks sat the same uncomfortable question. What happens if Iran shifts from simply having the technical ability to build a weapon to actually deciding to build one? Fordo was constructed in the shadow of exactly that fear. Western intelligence agencies revealed its existence publicly in 2009, catching Iranian officials off guard before they had announced it themselves. The most sensitive sections of the complex were believed to sit roughly 80 to 90 meters beneath the mountain. The underlying logic was obvious to anyone paying attention. Fordo was built from the start to survive an attack. A country doesn't bury an enrichment facility under tens of meters of solid rock by accident. It does so because it expects that someday another country might try to destroy it. Read that again, because the equipment sitting inside made the challenge even more complicated than the rock itself. Enrichment centrifuges look sturdy in photographs, long rows of metal cylinders lined up in tightly controlled halls. In reality, they're incredibly delicate machines that spin at extraordinary speeds and need near-perfect balance to function. A small vibration can damage them. A sudden power interruption can ruin an entire cascade. A powerful shockwave can wreck dozens of machines without a bomb ever entering the room they sit in. These aren't thick steel columns built to absorb punishment. They're precision instruments that only work in a stable, controlled environment. That's exactly why Fordo's mountain mattered so much. The rock above it wasn't just a ceiling. It was the central pillar of the entire defense strategy. Depth itself was the plan. For years, that plan appeared to work extremely well. But hitting a surface building is one challenge. Reaching equipment buried deep inside a mountain is an entirely different one. A weapon capable of that mission has to survive a violent impact with the surface, keep moving through layers of rock and reinforced concrete, and then detonate at exactly the right depth. The outer casing has to stay intact, while absorbing enormous force. The guidance system has to deliver the weapon to an exact point. The fuse has to delay detonation until the bomb reaches the correct layer underground. And intelligence analysts have to understand the geology, the tunnel layout, ventilation routes, and possible structural weak points, all without ever physically entering the site. A small miscalculation can waste years of engineering work. If the bomb breaks apart too early, detonates at the wrong depth, or enters at the wrong angle, most of its energy gets absorbed harmlessly by the mountain, leaving the protected chambers below essentially untouched. The weapon developed to solve exactly this problem is called the GBU-72, a massive ordnance penetrator built specifically to attack fortified targets buried beyond the reach of standard bombs. It measures roughly 20 feet long and weighs close to 30,000 pounds. Only the B-2 Spirit stealth bomber has ever been configured to carry it into combat, a detail that tells you how narrow this weapon's purpose really was. It wasn't designed for routine battlefield use. It was built for a small handful of targets whose depth and strategic importance justified an extraordinary level of engineering investment. Even with a weapon this powerful, few serious analysts believed a single bomb could eliminate Fordo entirely. Multiple weapons would likely need to hit carefully chosen points, possibly one after another, each impact weakening the layers above the buried chambers a little more. The goal was never to remove an entire mountain. The goal was to exploit the mountain's own structure and turn its mass against the facility hiding inside it. This is where the popular image of an underground fortress starts to become misleading. People often picture a buried complex as a completely sealed, self-contained world isolated from the surface entirely. In reality, no underground facility is fully independent. It needs electricity, ventilation, cooling systems, and supply routes for people and equipment. Depth protects a facility from direct attack, but it also creates dependency. A complex buried deep underground often relies on a limited number of shafts, tunnels, and access points. If those connections are identified and damaged, the mountain itself can start working against the people and machinery inside it. Once an adversary spends years studying those systems, a mysterious, seemingly impenetrable mountain gradually turns into a collection of solvable engineering problems. In Fordo's case, this kind of work continued for more than a decade. Accounts released after the operation made clear this attack wasn't improvised in any way. The GBU-72 had gone through years of development, modification, testing, and simulation before it was ever used in combat, and the entire target set that shaped this weapon's development closely resembled Fordo itself. So when people ask whether the mountain was actually part of the target, the honest answer is yes, at least in an engineering sense. The mission wasn't aimed only at the centrifuge halls deep underground. It was designed around the physical geometry of the mountain sitting above them. By the middle of 2025, the political crisis surrounding Iran's nuclear program made all of that preparation suddenly relevant. The 2015 nuclear agreement had once placed meaningful limits on Iranian enrichment and international monitoring, but that arrangement gradually fell apart after the United States withdrew in 2018. Iran responded by reducing its compliance, expanding enrichment activity, installing more advanced centrifuges, and building up uranium stockpiles well beyond the original limits. International inspectors repeatedly raised concerns about Iran's growing stockpile of uranium enriched to 60% purity, a level that doesn't automatically prove a weapon was being built, but sits far above what's normally needed for civilian power generation. In the period leading up to the strike, satellite images reportedly showed unusual vehicle activity near Fordo's entrances, along with what appeared to be earth and rock placed near certain access points, possibly as extra protection. Nobody could confirm the exact purpose from imagery alone, but the site clearly wasn't sitting idle. When the operation finally launched, the scale made clear just how seriously that question had been treated for years. Roughly 125 military aircraft took part, including the 7 B-2 bombers, along with fighter escorts, refueling tankers, and surveillance platforms. Submarine-launched cruise missiles struck targets near Isfahan from a separate direction entirely. This was a fully synchronized operation stretching across enormous distances, requiring precise timing, aerial refueling, stealth routing, and years of dedicated training. That political risk was enormous. Striking Iranian nuclear facilities directly could have triggered a much larger regional war. Iran could have responded by attacking American bases, allied territory, shipping lanes, or energy infrastructure across the region. And if the bombs failed to achieve their objective, the entire operation might have pushed future nuclear programs even further underground, making them harder to find and harder to stop. According to official accounts, all 3 primary sites were struck within a tightly coordinated window. Fordo reportedly took multiple Penetrator strikes. Natanz was also hit with bunker-busting weapons. Isfahan was targeted largely with cruise missiles aimed at entrances, tunnels, and supporting infrastructure. Altogether, the operation reportedly used around 75 precision-guided weapons. American officials described the strike as a historic success, while others used more measured terms like severe disruption and substantial degradation. The moment those weapons hit, a second kind of conflict began, fought not with aircraft or missiles, but with competing claims and arguments over what had actually happened beneath the mountain. When a target sits above ground, damage assessment tends to be fairly direct. Analysts compare before and after photographs, count destroyed structures, measure craters. Fordo offered no such clarity. Its most important chambers sat buried under solid rock, possibly behind damaged or collapsed tunnels that cameras and satellites simply couldn't see through. The International Atomic Energy Agency confirmed the nuclear sites had indeed been struck, but it also acknowledged that the full extent of internal damage at Fordo couldn't be immediately established with confidence, precisely because the facility sat underground and the weapons had affected areas that inspectors and cameras couldn't reach directly. That absence of direct visibility allowed two very different narratives to grow side by side. On one side, declarations of complete decisive victory. On the other, far more cautious assessments suggesting the operation may have delayed Iran's program by months or years without permanently destroying it. Some analysts argued enriched uranium or critical equipment might have been relocated before the attack even happened. Others pointed out that even if nuclear material itself survived, the loss of power, access, ventilation, and supporting infrastructure could still represent an enormous setback on its own. Arms control specialists have consistently emphasized that centrifuges don't need to be struck directly to be destroyed. Strong vibration, sudden power failure, pressure waves, collapsing ceilings, and even slight misalignment can wreck sensitive machinery across an entire cascade of equipment. A nuclear program isn't a single room that vanishes in one explosion. It's a network of facilities, equipment, material, trained scientists, accumulated knowledge, and supply chains layered on top of each other. One critical location can be devastated, while the broader capability still survives in a reduced, weakened form somewhere else. Before this operation, Fordo represented a category of target that many experts believed conventional weapons simply couldn't reliably defeat. Its very existence forced the United States to develop a specialized bomb, adapt one of its rarest aircraft to carry it, and build an entire mission plan around a single buried complex. Fordo appeared to prove that enough depth could create genuine sanctuary from attack. Once that assumption gets broken, even partially, the consequences reach far beyond physical damage. The impact becomes psychological. If Iranian planners once believed Fordo could operate with relative safety even during open conflict, a successful attack forces them to reconsider not just this one facility, but the entire underlying concept behind it. Iran's response to this new reality might involve spreading sensitive capabilities across more locations, building smaller and more dispersed sites, or developing facilities that are simply harder to identify from the outside in the first place. And that creates a genuine paradox for the United States and its allies. A successful attack can end up creating a whole new generation of targets that are less visible and far more complicated to track down than the one that was just struck. The aftermath produced far more uncertainty than closure. Satellite imagery revealed craters, displaced Earth, and damaged access points around the mountain's surface, confirming powerful weapons had reached their intended locations, but not settling the deeper question of what remained functional far below the surface. Inspectors had previously tracked more than 400 kilograms of uranium enriched to 60% purity. After the attack, the central concern wasn't only the physical condition of the three sites, it was also the exact location and status of that specific nuclear material. A damaged facility is one kind of problem. Nuclear material that suddenly can't be accounted for creates an entirely different, more urgent kind of problem. The world was left holding two facts that seem contradictory at first glance, but actually aren't. First, the United States had clearly demonstrated Fordo was vulnerable to a highly specialized conventional strike. A facility once described as nearly unreachable had genuinely been attacked and damaged. Second, the exact scope of Iran's remaining nuclear capacity after the operation stayed genuinely uncertain. That gap between dramatic military action and incomplete verified information is one of the defining features of modern conflict, and it leads directly to the hardest question of all. Did this operation actually make the region safer? Supporters of the strike would argue it did, at least in the near term, since a central critical facility suffered major damage, and Iran lost confidence in the idea that a mountain could offer permanent protection. Critics would respond that military force can delay a nuclear program without changing the underlying political motivations behind it, since bombs can destroy equipment but can't erase scientific knowledge already held by trained engineers and physicists. There's also a darker possibility worth sitting with, honestly. If Iranian leaders conclude that only a fully operational weapon can prevent future attacks like this one, a technically successful strike might buy short-term time while strengthening the long-term incentive to finish building the very weapon it was meant to stop. Governments around the world are studying this operation closely right now. Every nation with valuable military, nuclear, or politically sensitive infrastructure has to reconsider how it protects those assets going forward. Some will continue relying on depth. Others will lean more heavily on reinforcement, geographic dispersion, mobility, or deliberate ambiguity about exact locations. This doesn't mean underground bunkers have become useless. Rock, concrete, distance, and reinforcement still make an attack significantly more complicated and costly. But the lesson is now much clearer than it used to be. Protection is never truly absolute. Every defensive design carries its own underlying engineering logic, and that same logic can eventually guide a determined attacker straight toward its weaknesses. That brings us back to the central question running through this entire story. What really happened when 30,000-pound bombs struck Iran's underground nuclear stronghold? On the surface, the answer seems relatively clear. The weapons hit their assigned targets. A site once considered almost beyond the reach of conventional military force was shown vulnerable to a sufficiently determined attacker with the right combination of technology, intelligence, and patience. But the deeper result of this operation wasn't really physical. It was the quiet destruction of an idea. The idea was never that mountains themselves are physically weak. Mountains remain among the strongest natural barriers available to any defender. The assumption that broke was the belief that a mountain could permanently remove a target from military competition altogether. Fordo demonstrated that depth can delay an attacker, raise the cost of any strike, and complicate planning significantly. What depth cannot do is guarantee permanent safety forever. This entire episode is fundamentally a story about adaptation. Iran responded to superior air power by burying its most sensitive infrastructure deep underground. The United States responded to that move by building a specialized Penetrator weapon, integrating it with a rare stealth aircraft, and studying buried facilities for years until it could strike them successfully. Now Iran, along with every other government watching this operation from a distance, has to decide how to adapt once again. These questions stretch well beyond a single night of bombing, touching the future of deterrence, nuclear proliferation, and military technology more broadly. The true weight behind this attack wasn't only the 30,000 pounds carried by each individual Penetrator bomb, it was the accumulated weight of years of surveillance, simulation, engineering, and strategic debate happening quietly behind closed doors. And even after all of that preparation, real uncertainty still survived the operation. A reminder that even the most advanced military power in the world doesn't automatically produce perfect knowledge. This isn't a story where overwhelming force produced one clean, decisive victory. It isn't proof underground defense has become useless. It isn't the unquestionable end of Iran's nuclear ambitions. It's all of these competing realities colliding together in one location, a fortified mountain complex, a nuclear dispute stretching across decades, and an operation that may have permanently changed strategic thinking without fully resolving the conflict that created it. Perhaps the most important outcome of this entire operation didn't actually happen inside Fordo's tunnels at all. It happened inside the minds of military planners watching from around the world. Once a fortress this famous, this heavily hardened, and this deeply buried can be struck and genuinely damaged, every country relying on a similar strategy has to reconsider what safety actually means going forward. Fordo lost that kind of protective uncertainty long before this attack ever happened, having become too well known, too central to the international nuclear dispute, and too permanently fixed in one place. The longer it stayed important and stayed put, the more time an opponent had to map it, model it, and eventually design a weapon built specifically around it. That's exactly why the consequences of this strike will likely continue unfolding for years to come. The operation didn't only damage physical infrastructure buried inside a mountain. It exposed for the entire world to see just how narrow the distance can actually become between a shield and a trap.